right. There happens to be a good chunk of material in the class today, so I don't want to take too long before we get going. So, why doesn't this use the full screen when I zoom? It's a big annoyance. Oh well. All right. So we didn't have any real homework except for find an object and identify properties and behavior of it. But before we do that, I do want to go over recursive functions again. We talked about those last time. Did people remember what a recursive function was? I'm going to hide it real fast. Oh, did anyone read it? What's a recursive function? A function that calls itself, exactly. Which is crazy. What's going on? Anyways, so we learned about recursive functions. Recursive function is just a function that calls itself. You use them, they can really do anything that you could do with loops or anything else. Sometimes it's easier to think about stuff in terms of a recursive function as opposed to in a loop. And sometimes it's easier to think about it in a loop. But they let you do some really powerful things. One of the most common examples of a recursive algorithm that you're going to encounter whenever you're learning this is known as the Fibonacci numbers or Fibonacci sequence. Anyone familiar with the Fibonacci sequence?
I hear all the time. Notice we get it.
Yeah, so I've got a, oops, I want to go over to this version of it. And I gotta figure out how to fix my Zen mode for this. Yeah, Fibonacci sequence is where each number is the sum of the two numbers before it in the sequence. So they're all defined in terms of the numbers before them. So for the first 8 Fibonacci numbers, that's 0 and 1. Those are sort of your base. So you've got 0 and 1, and then the next one is 0 plus 1, you get 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, and so on. So that's the basic definition of the Fibonacci sequence or Fibonacci numbers. If we're going to write that out in a more mathematical notation as if a function, you could write it out like we have right here. Fibonacci of x is going to be equal to Fibonacci of x minus 1 plus the Fibonacci of x minus 2. This is a little tricky to think about. You're going, wait a minute, this is defined in terms of itself, and then the special cases are 0 and 1. If it's 1, then it's just 1. If it's 0, it's just 0. Those are the two special cases for Fibonacci numbers. So that, and remember, when I talk about special cases, that should make you go immediately back to what we talked about in recursive functions, which is you always need a base case when you're writing a recursive function. You always need a way out of calling the function again. So that sounds a lot like Fibonacci's of 0 and 1 would be ways out, things that you'll return that aren't calling it again. So let's go ahead and do this. Let's try and write a recursive function together that will compute the Fibonacci of any number that we put in. So it's going to take x as its input. Any good ideas on where to get started? So let's try this. Again, breaking it down into smaller parts. What's the first thing I typically do when I'm writing something new is I comment it out in more plain text before I write it. So let's go look at this real fast. Again, what we had. And I wrote it out in mathematical notation here. Fibonacci of x equals Fibonacci of x minus 1 plus Fibonacci of x minus 2.
Do you do the base cases first?
Well, let's think about it without those first, just because if we look at this right now, that looks awfully close to something that we could just write out, doesn't it?
Yeah.
So if I were to write that with the slight change here because I'm too lazy to type Fibonacci all the time, so I went with fib, how would I write that? I've defined the function of fib, so how am I going to write, this is sort of the other part of the equation, the equals bit. So we pass in x.
Oh, right. I guess that's what I meant. Parentheses equal.
Well, if you want to think about it this way, I don't have my pointer, do I? What a shame. Oh, here we go. Woohoo! I'm cool again. Yeah, that'll never happen. All right, so we have, you can think of this def as the left-hand side of the equation, right? So this is the fib x
Oh, I see what you mean.
of the left-hand side of the equation. The inside is the right-hand side.
So fib of x minus 1
Sure.
plus fib of x minus 2.
Sounds good. All right. So we're calling ourselves. We've got a start going on here. And I mean, that looks decent in some respects. So now we have something that works, but the problem we would have here is that we're never going to quit calling this function, right? There's nothing, we're going to, what we have right now, if we put in 1, then we're going to call this and we'll say, all right, fib of 1 minus 1, so fib of 0 plus fib of negative 1, and then those will just call back to itself and we'll have fib of 0, and that'll be fib of negative 1 plus fib of negative 2, and so on.
Conditions.
Right, so now we've got our recursive case written, so now we need our base case.
X.
Ah, because I write JavaScript.
Okay.
What?
The triple JavaScript?
JavaScript has the concept of a double equal type coerces. So a double equal in JavaScript of 1, the number, to 1, the string, will be equal. But triple equals, they will not be because they're not the same type. So
Okay.
by default, I...
Actually, if it equals 1, it's it's 1.
It's 1. So,
But if it's 0, you return 0.
yeah.
So instead of saying less than or equal 1, you should say if x equals 1, return 1. And if else if x equals 0, return 0. Else do the recursion.
Can you do that the same with a less than or equal to 1 and then return x?
Well, let's try. Let's give it a shot. All right. So we have, this looks like a good set of base cases. And this looks like a good case that's not a base case. Let's see what happens. One, 5, 21, and 610. So I don't remember what the fib of 5 is, so I need to go check my little cheat sheet that I put up here to see if this looks correct. 1, 2, 3, 4, 5. 21 and 610. Am I one off, or do I have this right? Let me try one thing here, just so I'm clarifying my code to myself. So this is where I'd have to write it out myself to check. So Fibonacci of 5 would be, and luckily I have my cheat sheet, 3 and 2. So wait, 0 or 1, 2, 3, 4, 5. Oh, I wrote the 1, 1 here. There's a little bit of a gotcha at the end there with the 1 and 1. So you could, there's a special way to match that, and it doesn't really matter. But yeah, I think we've got it right. You know, barring that little edge case, I don't feel like dealing with right now at the lowest level. So let's try it the other way that you mentioned, right? Less than or equal to 1, right? And you said just return x. That,
Yeah.
let's give that a go. Looks like we get the same results. Great. So this is a very, very classic example of a recursive function. It's relatively simple to write a lot of times, and yet I can't speak for you. Maybe you look at this and you go, hey, that's easy. I understand that. I probably struggled for an entire semester understanding how this stuff works in college. So I won't be surprised if it doesn't click right away and you struggle a little bit with these concepts. But great work on working through that together. So next thing I wanted to do was, we did this, I asked everyone to try and choose an object, a very simple object if you could, and describe some properties and behavior of the object. Does anyone want to talk about what they chose and the properties that they found or behavior on it? Yeah?
I did a rubber band
All right.
because it was there. And so I was thinking, I did like specific aspects of that one rubber band, and I was thinking attributes of just a rubber band in general as an object.
Right.
The different attributes that can vary depending on the particular rubber band you have, such as elasticity. I guess tensile strength would be one where, like, how taut you can pull it before it breaks.
Right.
How wide it is, the band, how long it is, and the color, the texture. Mine was kind of gritty. It's one of these like beige rubber bands, and it kind of has like grit from, I guess, the factory. And how flat it is.
All right.
But
And then did you have any behavior of a rubber band? What are actions or?
yeah, and then I was wondering if there was more things I was missing. So I thought the first thing I thought of was securing a bunch of objects together, which could be anything from a bunch of pencils or strands of your hair or a makeshift splint, securing these together. The other would be like closing and opening, creating a pulley system, part of a pulley system as a slingshot, which is what I used for a slingshot. And a musical instrument.
All right.
But I don't know if there's something else we can use with that.
No, I mean, this is just an exercise to get you thinking about objects and the different properties on them. I would think of some very basic ones, not even just high-level uses, but just simple actions that it takes, such as you can stretch it, or you can snap it, release it. You can just some of those types of actions. I think somebody might have just asked if they could. Oh no, this is in a different channel, I think. All right. Anybody choose something different they wanted to talk about? Properties or behavior of a different object that you chose?
Shoe.
A shoe.
Yeah.
Ooh, that's a pretty complex object. It's got a lot going on.
So you got color, you got fabric, where it's made, what day it was made, you got the shoelace, you got the sole, the type.
Right.
What size is size?
Size.
Yeah.
All right. And what are some behaviors or actions of a shoe?
You can wear
Yeah, this is the harder part because it's not.
it.
I mean, objects. It's a little bit weird, I'll admit, and I think that's just something you have to get used to because we can't model stuff perfectly. Because in reality, what happens is unless it's a creature or something that's alive, it doesn't have actions of its own. It has actions that somebody else uses it for, and so it's sort of exerted on. But in objects and programming, the objects typically have the behavior attached to them. So there's a little bit of a disconnect, but it's still a useful thing to think about. Yeah, you can walk on it. You can kick with it. You can lace it up,
Yeah.
right? Unlace it.
Is it butter? Yes.
Right? This is really just an exercise to get you thinking about objects and properties and behaviors on them, because that'll be, we're going to take a short break from it today, but that'll be what we're going to dive into more and more in the whole second half of this course, is working with objects, working with the methods on objects, the properties on objects, having how objects relate to each other. And you brought up a really interesting point, talking about the concept of a specific rubber band versus characteristics of all rubber bands. And in the real world, we tend to interact with real objects, like the pencils that I gave out, or this is a real object. But there is the question of how do you create objects consistently that have a common set of properties and behavior? How do we create a marker consistently that looks the same and has the same structure and characteristics and properties and behavior? And that's the second half that we'll get into later on with objects, is what can we use to create these things? How can we create a bunch of objects that are very similar and have different characteristics? So how is this how is a marker created? Not what?
How is it created?
You don't have to go into all the detail.
Oh, a template.
It's got a template. It's built in a factory, right? So that's pretty much what we're going to have as the other piece of objects. We'll have actual concrete objects, which is what we've talked about in Ruby so far, as real instances of them. And then we'll introduce the concept of how do we generate objects of a specific type? How do we make our own types of objects? Because so far we've only worked with existing object types, such as fixnum and strings and arrays. But we're going to be able to create our own object types, our own categories, such as a shoe or a rubber band. And then how can we produce objects of that type? And that's really what we'll be diving into, starting much more in the next class. I wanted to cover a couple other basic types in Ruby that we haven't covered up till now. And then hopefully, we've got a lot of material to go through, but hopefully we'll also get to being able to read and write from files as well. And then if I'm feeling particularly cruel, I'm going to try and give you a programming assignment that will have you basically spell check a book of some kind. We'll see how cruel I'm feeling and how much time I have to put into it. But after we get through the material for today, you'll basically be able to do that without too much of a challenge. So what we're going to go over today, the new types we're going to start with are hashes and symbols. Hashes and symbols are the two new types that we're going to talk about. So we're already familiar with arrays. Arrays are different from other types of objects that we've worked with in the sense that they're a collection of other objects. Right? An array is really just a collection of whatever it has in it. And they don't even have to be all the same. We're familiar with that by we can have an array of nil and true and hello and 42, and they're just all ordered in an array is an ordered collection of objects, is really the definition of an array at its base level. So now we're introducing another type that's related to arrays, but a little bit different. And this type is known as a hash. A hash is also a collection of objects. You'll also see it called a hash map or a dictionary. A hash is a collection of objects, but unlike an array, they're not an ordered collection of objects. A hash is a collection of objects that each object in the collection has a unique key for you to access it. I brought these up before in the past, and I gave what I said was a canonical example, real world example of a hash that some of you are too young to have ever used, but hopefully you're familiar with. Does anyone remember what it was? Phone book. A phone book is a great real world example of a hash. Because in a phone book, what it's doing is you're using one item, the key, which happens to be a person's name, to look up another value, and that value is their phone number. Or a dictionary, which is why they're also called dictionaries, is another great example of a hash, because a dictionary, you're using one item, the key, which is the word, to look up the definition of it. So those are both great real-world examples of hashes. Hashes in Ruby, like I said, they're similar to arrays because what they do is store other types. However, they're not stored in a given order. The order may vary when you read it one time from another time, so you can't rely on any order. To access an item in a hash, you need a key. In a phone book, you need the person's name. In a dictionary, you need the word. And the same goes for Ruby. So defining hashes, we look at this, boy, that looks awful lot like defining arrays, except instead of using square brackets, we're using curly brackets. That's how you define a simple hash in Ruby. This one happens to be empty. There's nothing in it, just like we could define an empty array with just the two brackets. And here we have a hash now that has one value in it. And if you're reading this, on the left side of this hash, you have the key. So Bob, the string Bob is the key, and the value is red. So if we were to, and then we can also do the same thing. This is defining it when we create the hash, but you can also define them later using square brackets to reference the key and then the value. Funny, you don't use the curly braces then, you use the square brackets. So that, one thing you'll notice is that this reads almost identical to the way that you handle arrays, except instead of an integer here, you're using a key, and that key can be anything. It doesn't have to be a string. So you'll get them mixed up occasionally, and sometimes it's even hard to tell if you're working with an array or a hash when you're in code at times, because they're very, very similar in how they appear. So let's go ahead and create one. Just like what I said, let's create a phone book hash here. So I'll go ahead and add an item. No, let's do this. This is better. Yeah, this is much better. And so this is just adding an entry into our empty hash. And now if we look in our phone book, we can see that we have Jenny and then the value. Now if we want to read that value out, we'll do it just like we did with an array index, except we need to give it the key. The key in this case is Jenny, and then we get the value that's stored at that key in the hash. So we can add as many other entries as we want to this phone book. I Actually, I should have called that someone else's. I think that's the phone number of my best friend when I was a kid, but I can't remember. Anyway, don't call it. Their parents will be mad at me. So now if we look at our phone book, you can see we've got a couple entries in there. And we can add any more that we want to add. So unfortunately, I don't know the, what is it like 910? I think 910 might be a Colorado area code. I can't remember. But hashes, like I said, they work a lot like arrays, except they've got this unique aspect of the keys being not just an index, but a key that you need to have to iterate through them. Any questions so far on hashes? All right. So going over some of the differences. Arrays are indexed by integers. Hashes can be any type. So let's add something else in. Let's create another one because I don't want to muddy up my nice clean phone book hash. So let's make a crazy hash. Crazy hash of nil equals true. I can do true equals false. And it's important to know that the values don't have to be unique. So false equals true. So we don't have to have true only stored in one place. We can have it stored in multiple keys. That's fine. Now we can't, however, have multiple keys that are the same. If I accessed nil again and tried to set another value, I would replace whatever was at the key nil, because there can only be one key with that name or that identifier in your hash at any point in time. So if I went, now let's keep it really confusing. So you can see that now nil holds the string nil, and anyone who looks in this hash is going to be incredibly confused by the output. What is that, an object? Is that the string? I don't know what's going on. Also, as I mentioned, the order of the elements in the hash is not guaranteed. They can change, and the order that they're returned in can change. What's going on actually inside the computer is hashes are stored in a very different way than arrays. We talked about how arrays are sort of like a linear series of data in the computer, and hashes have a whole different algorithm to optimize their storage, which is why the way that they come back can vary at any point in time, because reading them out, the data may have changed where it's actually stored. Similarities between arrays and hashes. Arrays and hashes are both collections of other types. They both are passed by reference. We've talked a little bit about that, meaning that if you change value on a key in a hash, or you add a new one after you passed it into a method, you're going to change the hash externally as well. And they have a length. So we have phonebook.length, which tells us how many items there are in our hash as well. So I already said hashes are a new data type. Does anyone remember what we learned last class on how you can check what type an object is? Yep. All right, so the class of it is hash. That's what you'd expect, right? We have a hash object here. So let's do a few quick exercises just to reinforce this a little bit. I'll go ahead and snag this and put it into my working space. Let me do this so they can be side by side for a while. All right. What do we have at, what are we going to get with A, B? What's that? 34. All right. Now what about A, B plus B of 1? What? Yeah. Again, that's another example of what could be a very confusing key because we used a number as a key. That's perfectly legal in a hash. And then you refer to it just like this. So if I read just this line, I'm thinking I'm working with an array, but I could easily be working with a hash that's just using numbers as keys. A dot length. 2. Right? B of C dot length. 1. All right, I'm going to jump down a little bit here. Let's do C of nil and C true. It's very confusing. What? What?
False, and false.
So we had nil, we've got false, we had true. Nil. All right. And now let's try A at C. String C. Nil. Yep. We get back nil. Remember, just like in, should I have R in here? Just like if I tried to access something that's outside of my array index, if I try and access something that doesn't have a key in my hash, I'm just going to get back nil. That's both a nice and also unexpected behavior if you're used to other programming languages feature of Ruby, which is that it's not going to throw an error necessarily on those accesses. It's just going to give you back nil. So we've got our hashes here. Now, looping through a hash. Looping through a hash is very similar to looping through an array. But there's one difference that matters, and that's that you don't just go through them point by point based off the index. So one thing you can't do, at least not in the same way that you could do it with an array, is you can't do, say, a while loop where you're incrementing a value and accessing each index in the hash, because they don't have indexes. So you need to get the list of keys out of the hash to do that. But lucky for us, hashes have the .each method, just like arrays do. But there is at least one thing different between this .each and what we did for arrays. Anyone notice it? Yep, it's taking 2 parameters or giving 2 parameters into the block. And you can always reference this. In fact, I encourage you to go look up the documentation for these items. Here's the documentation for .each on hashes in Ruby. I've got a link to it when I post these notes later tonight. And you can see that it'll tell you this takes a block with a key and value parameter to that block. As opposed to if I went and looked at the array, it would have different documentation as to how it worked. Any questions on any of that so far? All right, you're flying. Sweet. So now we have one more new data type I want to introduce, and that's symbols. Symbols are a lot like strings, but they're also nothing like strings. It's the symbols are sort of a magic data type. You write them out like a string. A symbol looks like a string. So if I were to write, except you use a colon first for a symbol. So it's colon and then the text. You don't quote it or at all. It's just colon and then the item. But the reason we use symbols, there's a few reasons. A, we're lazy, and it's slightly shorter to type colon in an item than quotes around at the beginning and end. It's also a lot less error prone when you're making a lot of changes and stuff, because you're not likely to miss the quote at the end of a string, which when you've programmed a lot happens all the time. But one of the more important reasons that we use symbols is they're very efficient for the computer as opposed to a string. So the computer can store symbols efficiently, and it really can't with a string, and then look them up very efficiently and compare them very efficiently. Symbols can be pretty much anything. So we can have A equals the symbol B. We could have C equals the symbol B. We could have hi equals the symbol hello. So if we type hi, we'll see it's telling us this is the symbol hello. But they won't have any of the same methods as strings. You can't split a symbol or add symbols together. Introducing symbols now at the same time we introduce hashes, because we just did some hashes with strings as their keys. It's a much more common pattern in Ruby to use symbols as the keys on hashes. Because again, symbols are very, very efficient. And since the key isn't usually what you're working off of, you care more about what you're storing there. So a symbol makes a lot of sense. I haven't tried this, so we're gonna see how this works, but you can convert a symbol to the string representation very easily if you need to. 2s works just like it does on other objects. So now, we look at the class for a variable that has a symbol. It's just symbol. Now, one of the things that is interesting about symbols is that they're unique in the code. We've run into one other object that was unique, where you don't get more than one of them. Does anyone remember what it was? Nil, right? What? No. So what I mean by unique is if I look at a.objectID, I've got a specific object ID here. But then if I look at c.objectID, you'll notice that those match. And that's because once that symbol's been created in our program, anything that references that symbol references the same symbol, just like anything that references nil references the same instance of nil. There's only one instance. Symbols are also unique, but only once they've been created. They don't exist ahead of time. They exist when you first create them, and then everything else will point to that symbol in your code. Does that make sense? There's only one symbol. When everyone's unique, then nobody is. Sorry, Incredibles. Yeah, you could also do it like this. Because they're the same. All right. So quick review of all the different types that we've learned so far. There's not the gap in here that there is in my notes, so it loses all of its cool factor. No, we've got all of our what you might call primitive or basic types here. You've got integers and floats, strings, booleans, nil, and now symbols added to that list. And then we have these two types that are collections of other objects. And those are arrays and hashes. These are really the the basic set of primitive objects that we've worked with. There is one other one I didn't list on here that we worked with last class. Does anyone remember it? That was the bare object, just the object class of Ruby directly, as opposed to one of these super types. That was where we were doing object.new and some of that. Awesome. We're flying. Yeesh, there's a lot in this one. All right. I'm gonna admit, I didn't check all of this like I sometimes do. So we'll see if there's any bugs in this code like we've encountered at other times. Who knows? So let's try some of these. I'm gonna output all of them at the top so people can at least see them. Go through some more of these, just some more exercises, some more rote work here. A of 0 plus H at Bob. What are we going to get here? 24. All right. What about H of X?
Yeah. Oh, wait.
Oh, 19.
It's a tricky one, yeah. 19. People see why? Because
Oh, I
X
see.
is Alice, and then Alice is the key to 19 there. When you're looking at code and you see something like this, just X plain in the code, you got to think about, at least in Ruby, what could this be? Do I see a colon in front of it? There's no colon, so it's not a symbol. Okay, is it quoted? It's not quoted, so it's not a string. Then it's got to be a variable, right? And if it's a variable, I must have a variable assigned to it, or maybe I don't. Like H of Y is going to yell at me because I don't have a variable for it. So let's try, yeah. Go with, what are we going to get as a result of this one? Let me scroll over up here so people can see it. What's that? False, because it was not the value that we had there. Let's do one of these more interesting ones. GG, Parm. Good game, Parmesan, good game. That was just geeky. It didn't even deserve a chuckle.
Years.
And then, could you scroll all the way to the right on the?
Oh, so
Oh, it's up here. My bad. I'm sorry.
I have them up there too, but yeah.
Yeah, it should be middle, right?
It should be nil. Let's see. So G, again, breaking it down. G of Parm. Well, I don't see a Parm key on it, so yeah, we'll get back nil. Let's change this to be pizza now. What's that? Nil? All right. Now, I don't even know what this is going to result in. I'm going to give you guys this challenging one at the bottom that I haven't even looked at. Okay, what do we got?
Oh, scroll over what's 19.
That's not fair.
Computers
Nope. You guys, it was close. It was close. You got to break it down piece by piece very carefully. So you did a good job with A at 1 is 9. And then we got G at 9 was
Oh.
ABC. So then the expression we had in here was
Here's the wrong one.
Okay. Okay.
right? You gotta break them down piece by piece when you're looking at code. You're not usually gonna run across code that tricky. That's a horrible example. But it's good to make you think about thinking of code in small blocks, small pieces, one at a time. And order of operation, yeah. All right. I don't think I need this here anymore. So let me get rid of it and then we might come back in a minute. Oh, I prefer it on that side. All right. Cool. You guys doing good. So let's build something more complex. We're gonna write a program that creates a database to store the ages of people. And then we can ask the program for a person's age. So this is more complex than anything we've written so far, and it introduces at least one thing that we haven't really looked at, which is just this loop portion. I think we've encountered it one other time. It's basically just a loop that doesn't have a direct exit. You have to break out of it. So you have to have a special command inside that says get out, and in this case, that's break.
Can you switch statements?
Yeah. Off the top of my head, I don't know the syntax. So yeah, it's a case statement. Slightly different,
Yeah.
but same thing. Oops. Okay, so in this, we're gonna have Bob, Alice, Peter, and Chris. Let's give this a go. Who should we look up the age for?
Look up the age for someone.
Yeah, who should we look up the age for? What?
I don't know. I got it.
We had Bob, right?
Yeah.
Right. People, this is a little more complex. We're going to build something. We're building on top of this, so we're introducing it step by step. But do we understand what's going on in this so far? We've created a hash. We're adding some keys and values into that hash. The keys are the names. The values are their age. And then we put this loop statement in. This is sort of the body of our program, if you will, where we ask for a name, we get the value that you put in, and if it's an empty string, so if you just hit enter, and then we kick out of the program. Otherwise, we look up that person in our hash and output their age. Go away. If we had a name that wasn't in there, it's going to give you the name, but it can't give me an age because it's nil. Does that make sense to everybody so far? All right. So let's continue to build on that. So as I said, you sort of have a bug, if you will. Sam is, and we just had blank when I tried Jenny said that because it's not checking whether the value is actually there. So let's add some code to this program now that will check for, it'll give a message that person not found if they weren't in the hash. What? Put something before the break? What's that?
Your name is not.
Name not found. Let's try that out. So we know Bob was in there. We tried Jenny and no. If I hit enter, it wrote it. That's because this is what we do when we break out. It's when you don't put any name in.
That's also because you are writing a name. That's what it's not processing.
What?
So it didn't put name not found because you didn't enter a blank.
Yeah, you did enter a blank, yes. So instead, any idea on where we can put this?
Could you wrap? So could you say like if?
Where are we putting the if? I'll put something here. I'll just put it and then we'll move it where we need it to be.
So I guess if could you take that look a second?
Yeah.
Yeah. If people sort of bracket name, you know, then put name else.
All right, let's give that a go. We got Bob. Great. Looks like we're working. That's one of the cases you'll have to deal with when you're working with hashes is what do I do when I checked for a key that's not actually in there? Now remember, that can also be just slightly dangerous because we could have had, although in this case it wouldn't make any sense, we're not going to solve that right now, so don't worry about it. All right, getting back down here. So now we're going to expand on this program. We're going to make it more complex. Instead of having this predefined list of people and ages, we're going to be able to input our own information into it. So this is a more complex program. It's really building on a lot of concepts that we've introduced up to this point. So I wouldn't expect you to just be able to sit down and write this out, but I hope that as we go through it, everything in it makes sense to you at this point in time, that you're able to understand all the different bits and pieces. So the first thing we have is an add person method. This will print name, get whatever the user inputs, print age, get that and convert it into an integer, and then store them into this people hash that we created above. Then we have search. This allows us to find someone in our hash. So you put in a name and it'll help you find someone. And then we have a main loop here. It's a little more complex than anything else that we've done, but again, everything should be code that you feel pretty comfortable with at least reading. So in this loop, we're just going through, and you can either add somebody to your database or you can search for someone. Does this make sense to everybody what's going on in here? So you can begin to see this, a great example of a more complex program doing something that's not, I'd say it's non-trivial, especially compared to what we've been doing so far in class, where we actually have some real capabilities going on. We can do something real. So we can add somebody. And I don't know what to do, so I'm going to hit on command, enter add to add a person, enter search to search for a person. So let's add someone else. And then we can search instead. And get back the results. Search. Now we have our old bug back because we didn't check inside of our function how to solve that. But that's okay. Hope that, I mean, that may not be the most exciting example, but I hope it begins to get you thinking about the tools that you have so far and the types of programs that you'd be able to write with them. Now, there's one obvious shortcoming to this program at this point in time in terms of being a useful database of names and ages.
Does it say that after?
Right? The minute I exit the program, my data's gone. I have to enter it again every time I run it. So the next thing, and this isn't exactly tied just to that, but it makes logical sense to flow from it, is the concept of being able to read and write from files so that you have a way to save information and bring it into your program from outside. So far, everything that we've done has been within the program itself. We've requested user data, we've asked for some input of some kind, but we're just as able to read stuff from files and get our data that way. And that gives us a lot more flexibility. So this is all, don't read this stuff. I need to fix it. She's referenced, it's like placeholder content. None of that's real files. But I do have this Programmer's Code of Ethics sitting in the same folder, which is just a text file. With a bunch of information in it. And we can very easily go ahead and read that file and spit it out in Ruby. So let me get rid of the code I had here in my Scratch. Oh, this isn't going to work because I have this. I have to change my path to make sure I'm getting it from the right place. This code isn't running in that same folder. That should work. So there we go. It's pretty simple. You don't really need to explain it. You just need to sort of learn how to use them. In this case, hey, how it jumps over to here. You're using open, and then you're giving it a string, which is the name of the file. It looks for that file. If it's just like this, it looks for it in the same directory as the code that you're running. You saw me change it, and that's because I have my code in this examples folder, but I needed to read the file out of this week 5 folder. So if you go back to our very first class where we talked a little bit about navigating in the command line, we talked about how you can go up or down directories using .. is one way to navigate around a little bit. And ls, at least in Linux, can list. So if we, and / means folder. So if we go back and look at what I wrote that was slightly different, you'll see we've got the .. which is just saying go down a directory and then go into the week 5 directory and get the file. Then once using this open method, we're able to open the file, and then we need to be able to read it. So file.read will read the full content of the file. And then we just have text at this point is just a string. And we can do whatever we want to with that string that we just read in. So we just put that string to the screen, and we do file.close to make sure that we've closed our handle to the file and that we don't leave the handle open. It's not as important in this very, very short example where you're just reading a file, but close is critical, especially when you're writing files, or if you're working with files in a bigger program. You need to close that open handle to the file, because otherwise the operating system itself maintains this connection between your program and the file. And that's, I don't know if anyone's ever encountered a situation where they try to maybe close a program or something, or delete a file, and it yells at you, says, you can't delete this, something has a reference to it somewhere. You know, can't delete me right now. Something like this where somebody didn't close a handle to a file, or there's a program still with the handle open. That's what's going on under the covers when you run into that. Look at the time. Wow. We're doing really well. We're gonna finish a little early, maybe? Yeah. So we've been able to open a file now, right? The next thing is, how can we write to a file as opposed to reading the file? Well, you open it like you did before, except we passed something else in. I'm going to try and find I'll hop over into the Ruby documentation so we can look at this in terms of what the Ruby documentation says. But you notice we passed something else here. What do you think this second parameter of a quote W means? Right.
Or is it,
Because we're all lazy programmers and we don't want to type out write or do something that's nice and easy to read and understand. So we just put a quote W here to say write. I want to be able to write to this file. So give me a handle that allows me to write to it. Whereas before we could read, this one says I want to be able to write to it. And now we can add something to the file or a file just by doing that. So we'll go ahead and change up our code in here, and we'll see what happens. Okay, now if I look, I've got a hello.txt file here. So what happens if I grab that? This is text, this is more text. Okay. What? Yeah. I was waiting for somebody to mention that. I missed the close when I grabbed this. You want to make sure that you close the file. It mentions here, like, in order for the contents to be saved to disk, it's sort of happened coincidentally that the contents were saved to disk here, and the reason was because when my program exited, it's the equivalent of closing the file. If instead, I'm gonna be a little lazy here and steal my code from this other example. Because being lazy is fun. I don't care about that. I don't care about that. So now let me delete my file. And we'll run this again. I don't know if this will work the way I expect it to work. And then I'm going to need another tab. Bigger. So now, when I read the file hello.txt, you can see that there's nothing there. And that's because my program hasn't closed its handle to that file yet. And until it closes it or flushes or something like that, you're not actually going to write that content. The file existed, but it wasn't written in there because I didn't remember to close my handle to that file so that it actually wrote it out. So if we go over and see if I can find the reference here. I am really bad in the Ruby documentation because, frankly, I think their documentation site is awful.
It's awful.
What?
You think it's awful?
I think I think it's just horrible to read. It's some of the ugliest documentation. There's a lot of other sites that people use instead a lot of times because it's just sort of formatted ugly, and you see a lot of things that you probably most of the time don't care about working in Ruby. Do I care about these C files that are the base for it? No, probably not. So if we go here and we look at file open, we can see that we've got several different versions of this method that we can call. And in one of them, when you see these square brackets, that means the parameters inside of those are optional. So we have open file name. Well, that was the first version that we used, was open file name with just a file, and we didn't pass in a mode or a perm or ops. But if you go down and look, you can see what some of those also mean sometimes. With no associated block, file.open is a synonym for new. If the optional code block is given, we pass the opened file as an argument. And then you might, it depends on how, you see io.new for a description of the mode and opt parameters. So this is where I was saying, I think the documentation is just frankly not that user-friendly. But if you see, it's returning a file object when we've accessed it. So if we, let's do this. Get rid of my ridiculous little blocking code here. Well, you can see file, right? The class of what we got back from this open was file. And that's what it tells us we should get back. We should get back a file object. Again, like I said, I don't think that this is that easy or friendly to read. I can't even figure out the extra parameters off of this. There's some other places that document some of this a little easier sometimes. What? You can, yeah, you can go here, but there's also, what am I looking for? Hold on. It's not here. Let me try and find it. They may not have it. There's some other sites that have sort of mirrored some of the Ruby documentation in some slightly nicer to read formats that might.
Isn't that right?
What's that?
Ruby learning or something?
I'm sure there's plenty of resources if you're looking for examples. I try to, when I'm looking stuff up, I'll look at examples, but I also try and go back to the source. That's why I'm specifically referencing this site, to make sure that I'm looking at the correct information, because you'll find, frankly, just as many wrong examples online randomly as you will right ones. So while you can look at them, if possible, it's really powerful to learn how to read the source documentation so that you know that it's correct. You know, we could dig into this, but it would take more time than I think it's worth for us to try and figure all this out. If we did if I was trying to figure this out right now, I would probably search for mode. And it says see io.new for description of mode. So here it tells us what the different modes are. IO open modes, R is read only, which was the default. R plus is read and write, starting at the beginning of the file, so you can read the file and write the file. W write only. So that's what we were doing before, and what that'll do is it says it truncates the file, so you're gonna have a new file when you open it with just a straight W. W plus is read and write. A write only, each write calls append data at the end of the file, so instead of blowing away your file, you're going to add it on to an existing file. So it's different options for that. And then if we look at this file object, the methods that exist on it, there's a lot of different methods that we can use against a file. We can check if something exists. We can look at its extension name when we have a file. We can look at the file type. So if we were, let me see. Where am I? I'm in examples. I don't know if this will work. That's not what I wanted. So let me go back, and what was the his extension name, right? Oh. That's going to be confusing for you. We'll talk about that later.
Oh, is that to change the extension name?
No.
Extension?
I won't, don't worry about that. We'll talk about that later. Yeah. We'll come back to that when we talk about classes. Because the reason that didn't work is because that's a class method instead of a object method. So we talked about, you know, I hinted that we're going to talk about factories, and factories are objects too, right? It's the same way that actual objects are. So factories have actions that they can take as well and properties on them. And in Ruby or most object-oriented languages, your factory is called a class, and sometimes it has its own actions and own behavior. Which is why this didn't work the way I thought it would. Let me see.
So we're going to be spell checking a book?
Yeah, I think that's a lot of material to go through. You guys seem like you grabbed it just fine. So let me know if you have any questions now. I don't know if I'll try. My goal would be to have you try and spell check a book. I want to do it myself just to see how complex it's going to be. I haven't done that in a long time, but if I do, I'll provide the dictionary and the book,
So can you-
and the book will probably have all syntax stripped out of it so that you don't have to worry about trying to deal with pulling off periods or anything else. It'll just be a book with, words, no syntax whatsoever.
I did find the way finally, because I was remember before where you could put in a sentence and it would tell you the first and the last, and I wanted to figure out how to get rid of all the non-characters, and I did find the way to do it, so.
that would probably be something that I would have up at the top before
Right,
running through the book, so it just ignores everything that's not.
exactly. You could strip them off of each word when you pull it, or you could strip them off at the beginning at any point in time. Yep. All right. Well, let me stop my recording. That's for sure. No.